Hey class, so just a reminder on how to do LFSR. We went about this in class, but I just wanted to show you the idea of LFSR is we have some register. In this case, I have an 8-bit register. I started with the seed 10110100, and I'm going to use the tap position to be the 5th bit. And I'll show you what output I get as a result of this. So, in the case of this output, the first bit output is going to be the XOR of the most significant bit and the tap position. So 1 XOR 1 is 0. I then shift every bit to the left. So just to show you how that went again, 0 is going to move from 6 to 7. 1 is going to move from 5 to 6. 1 is going to move from 4 to 5. 0 is going to move from 3 to 4. 1 is going to move from 2 to 3. 0 is going to move from 1 to 2. And then 0 is going to move from 0 to 1. And then this bit is now empty. We're going to, oops, this should have been, I accidentally wrote 2 there. Not intended. This is going to be the new bit. So whatever bit I output, that's the bit I'm going to put in the least significant bit. So now I look at the most significant bit and the tap position again, and this time, this is when I call next bit again, I should say. So I've called next bit one time. Now when I call next bit a second time, I once again do most significant bit and tap position. I do an XOR. 0 XOR 1 is 1. I then shift everything, and I can do this by, in this case, copying and pasting, though you will, of course, need to use a loop in your code. And then I replace the least significant bit with the bit that I output, which was 1. So now I've hit twice, and I have 2 bits. So I've called next bit twice, and I've outputted 2 bits. The next time I output a bit, I do XOR 1 and 0, and that gives me 1. I shift every bit to the left, and then I place the bit that I generated into the least significant bit again. So now I've generated 3 bits, generate a 4th, 1 XOR 1 is 0. Shift everything over, and then this becomes the new bit. And if I keep repeating this process, I can generate a large number of bits. How many bits can I generate? Well, I can generate 2 to the power of n, where n is the size of my register, minus 1 unique bits without a cycle. By a cycle, I mean, if I were to generate, in this case, I have 8 spots in my register, therefore I could generate 2 to the 8 minus 1, which is equivalent to 255. I can generate 255 bits. However, after I've generated 255 bits, the 256th bit will necessarily be the same as the 0th bit. And the 257th bit will necessarily be the same as the first bit. So 256 will equal 0, 257 will equal 1, 258 will equal 2, and so on. This is the basis of the LFSR. So if you want to generate more unique without creating a cycle, you just add more bits to your register. In this homework assignment, starting with LFSR is key. You want to make sure this works. One thing I want to note, if I implement this as an integer array, realize that these numbers up here, 7, 6, 5, 4, are the bit numbers. They are not the array numbers. So if I were using this as an array, this would be index 0, even though I think of it as bit 7. And this would be index 1, even though I think of it as bit 6. So when I say the tap position is bit 5, in my array, if I work out my array left to right like this, the tap position is actually the second index, or the most significant bit, that is the last bit in the register, minus the tap position. So just keep that in mind as you work on this assignment. Best of luck. Take care.